Welcome back. Today we are here to learn how to multiply two matrices. We cannot multiply just any two matrices. We have to check whether the two matrices they are compatible to each other for multiplication or not. Now how to check that? We have to check that the number of columns of the first matrix. It's A here, the first matrix is A. So the number of columns of the first matrix should be equal to the number of rows of this second matrix. Okay, so the columns of the first matrix should match with the rows of the second matrix. Only then we can multiply. So suppose we have matrix A of order R1 by C1, matrix B of order R2 by C2, and matrix C of order R3 by C3. Now the first thing we're going to check is whether the number of columns of the first matrix and number of rows of the second matrix, whether they are equal or not. If they are equal, then only we can multiply. When we multiply two matrices with these orders, the order of the matrix we get is, you can say, the number of rows of the product is equal to number of rows of the first matrix. So you can see the blue line over here, R1 goes to R3, and we can see that the number of columns of the product should equal to number of columns of the second matrix. And to check the compatibility, you just need to check this red line. Okay, so you have to check the column of the first matrix and the row of the second matrix, so they have to be equal. Now if you keep this figure in your mind, it will help you order of a particular matrix. Suppose you have in some question they might give you matrix A and matrix B, so it's easy to find matrix C. Once we multiply matrix A with B, we get matrix C, and we get the order from the multiplication. Okay, now in some cases they give you matrix B and matrix C, and they ask you to find matrix A. Now if you remember this, then you can easily find the order of the matrix A first, then you can go on to find the matrix A. In some questions they might give you matrix A and matrix C, so you can easily find the order of the matrix B, and then you can go on find the matrix B. Now let us check the process of multiplication. Now be very careful when you multiply the elements. Okay, for the first matrix we need to check this order, and this is 2 by 2. And see the second matrix, number of rows 2, so 2 by 3, the number of columns is 3. We can see that the number of columns of the first and the number of rows of the second are exactly equal, so they can be multiplied. Okay, if you take the second matrix first and multiply the first matrix, you will not be able to multiply them, because number of columns of the second matrix is not equal to number of rows of the first matrix, so you cannot multiply the second matrix into first matrix. Okay, so let us understand how the multiplication is done. So we have to move in the right direction for the first matrix, and then we move in the downward direction for the second matrix. Okay, that's why you need the number of rows equal to the number of columns of the first matrix. Okay, so if it is not equal, you will not be able to multiply. So what you are going to do is A into P plus B into S. See, the first element of the product is AP plus BS. So now what we have done, we have done the first row with the first column to get the first row first column element for the product. Similarly, if we do first row and second column, we get the first row second column element of the product. So that's AQ BT, AQ plus BT. Now if we do the first row and the third column, we get the first row third column of the product. So AR plus BU. Now we move to the second row of the first matrix. So CD multiplied with the first column of the second matrix, we get the second row first column of the product. That's CPDS. Understood? Similarly, with the second column, we have second row second column for the product, CQDT. We add them, CQ plus DT. And the last one, second row third column. Okay, second row third column product element. So CRDU. Once again, first row first column, we get the first row first column element of the product. First row second column, we get the first row second column of the product. First row third column, we get the first row third column of the product. Similarly, second row first column, we get the second row first column of the product. Then second row second column, we get the second row second column of the product. And second row third column, we get the second row third column element of the product. Okay, that's how we multiply two matrices. Okay, in this question of exercise 8.3, we have to check whether we can multiply AB or not. So product AB is possible or not. If it is possible, you have to give a reason for that. If it is possible, you have to find AB. Okay, so first of all, to check their compatibility, we just need to find their orders. So the first one is 2 by 2 and the second one is 2 by 1. Okay, so the number of columns is 1. Now we know that this column of the first matrix should match with the column of the row of the second matrix. So number of columns of A is equal to number of rows of B, and both are equal to 2, and therefore product AB is possible. So what about BA? Is BA possible? That means if you multiply A later, so if I have BA, is it possible? So what we are going to do is you are going to check the number of columns of B, that is 1, and the number of rows of A, that is 2, which does not match, and hence BA is not possible. In some questions they ask you whether AB and BA are equal. So AB and BA both are possible when we have both the matrices as square matrices, and then you have to find out AB and BA separately, and most of the times you don't get AB and BA equal. Okay, now let us find out the product of A and B. Okay, to find the product A and B, AB, remember we need to go to the right for the first matrix and downwards for the second matrix. So what is the first element? We have first row first column, so that's first row 3 into 2 and 5 into 4, so 3 into 2 plus 5 into 4. Now since in the second matrix we don't have another column, so we cannot go to the next column. We only have one column. Now second row first column, so we should have second row first column 4 into 2 plus minus 2 into 4. Okay, there is no second column for the second matrix, so we only have 2 rows and 1 column, so the order is 2 by 1. So you should get 6 plus 20, 26, and here we have 8 minus 8, so the second element is 0, so that's 26, 0. In this question you have to find the product of 3 matrices A, B, A, but you have to multiply B and A first because they are inside a bracket. And then you have to multiply the product with the matrix A. So the process of multiplication is same. We have to find BA first. So this is our product BA. Using the process of multiplication, 2 into 1 plus 1 into 2. Okay, and for the first row, second element, we have first row 2 into 2, 1 into 1. Okay, similarly for the second row, 1 into 1 plus 2 into 2. Okay, and the last element, 1 into 2 plus 2 into 1. Okay, so we get 4, 5, 5 and 4 for BA. Now we multiply BA with the matrix A. Okay, so BA with the A to be multiplied. So the same process, and we get 14, 13, 13 and 14. This is the final answer. This question is also like the previous one, but there is no bracket, you can see. It's just ABC. You also have to find ACB. So the process is same, but we have to find different matrices, okay, and different products. So here, when you don't have a bracket, what you do is you have to multiply the first 2 matrices first and then the product with the third matrix. Okay, so we are going to find A into B first, then we will multiply the product with C. Similarly, for the second part, we will multiply A and C first, and then we will multiply the product with B. So this is, you can say, I have multiplied AB first. This is A into B, and this is the product AB, and this is matrix C. So this is the product AB, and this is C. So again multiplying, we get, this is the final product of ABC. So we have minus 15, minus 7, minus 30 and minus 14. Similarly for ACB also, we multiply AC first and then the product with B. So this is our matrix A and C, and this is B. So we'll find the product of AC first, and after multiplying, this is the product. Again, this product to be multiplied with the next product ACB. So this is AC and this is B. So this is ACB. Minus 18, minus 24, minus 36 and minus 14. So we can see that ABC and ACB are not equal. Okay, in this question we have 2b minus a square. We have to find the value of this. A is given and b is given. So a square, now you have to multiply a 2 times. So it's better you find a square separately and 2b separately, and then we find the value of 2b minus a square. If you write the whole equation and go on continuing to calculate, it takes a lot of space. So it's better you find a squared separately. So that's A into A. We have multiplied these two matrices, matrix A 2 times, and after multiplying we get the product minus 300 minus. So 2B, 2 times the matrix B, and A square we have got minus 300 minus 3. So when we multiply the matrix B with 2 each of the elements, so 2 into 3 6, 2 into 2 4, so 6 4, 2 into minus 2 minus 4, and 2 into 1 2, and then we do the simple calculation. So the final result is 9 4 minus 4 and 5. That's all for now in this class. We'll see some more questions from this exercise in the upcoming class. Thank you.